Hi guys, today let's solve one of the famous interview question. Show that for any set of 10 points chosen within a square of side 3 centimeters, there are 2 points in the set whose distance apart is at most root 2 centimeter. Please read the question once again. This might seem tough at the first go, but I will make it as clear as possible for you to understand this. Please pause the video for a couple of minutes and try to solve it on your own. I hope you tried this question. Whenever you see such kind of brain teaser question, first try to understand the question thoroughly and start solving it. Let's understand the question clearly first. So here the question says, for all set of 10 points, that means for every possible set of 10 points, the maximum of minimum distance between 2 points is root 2 centimeters. Let me further clarify this question diagrammatically. Here is the square of side 3 centimeters into 3 centimeters. Now you have arranged 10 points randomly. Okay. Now for every such possible configuration, here we are showing such kind of 3 possible configurations. This is one kind of possible configuration. This is another kind of possible configuration, and this is another kind of possible configuration. Let's say let x1 be the minimum distance in configuration 1, x2 be minimum distance in configuration 2, and x3 be minimum distance in configuration 3, and so on up to infinitely many such configurations. Let's denote like xn, and n tends to infinity. What we need to find is maximum of x1, x2, x3, so on up to x infinity. Obviously we cannot write down all the possible configuration, find the minimum value and take the maximum value of those, right? So there should be some clever way to solve this question, right? Let's take a moment and understand how do we solve this question. Before that, let's jump into the question for some time. It is asking us to prove distance apart is at most root 2 centimeters, right? Somehow we know root 2 is square root of 1 plus 1. That means length of diagonal in a 1 into 1 centimeter a square, right? So this might give us a hint that there is something we need to deal with 1 into 1 side, 1 into 1 square centimeter, right? So let's think in this way. Let's divide 3 centimeter into 3 centimeter square into 9 1 into 1 centimeter squares. Okay, so basically we divided it into 3 by 3, right? Here each small box is of 1 into 1 centimeters, right? See this, so this is 1 into 1, this is 1 into 1, this is 1 into 1, so total there will be 9 into 9 1 into 1, right? And we had 10 points. Okay, now as the question says, we are having 10 points of chosen set, and the clever idea comes here. One thing to note is, if you arrange each point in the bigger square, there will be at least one box which contains at least 2 points. Okay, let me reiterate this point because this is the crux of the question. Okay, this maybe seems simple, but you can use this idea in many kinds of very hard tasks. Okay, so now we had 10 points and we had only 9 squares. Okay, that means for at least one square should get more than more than one point, right? Okay, now what we had is like we had 9 squares and 10 points, and we need to assign these points to each square. That means there exists at least one square with more than one point, right? I just take a moment and understand this. Okay, uh, so so one of the possible configuration is this thing. Okay, and you assign each point to each square, and now we are left with one point. That one point should go to any square, right? This means that there exists at least one one small square with 2 points in it, right? So basically this is pigeonhole principle. I said it in an informal way. We can explore this in further videos. Um, so as I said earlier, we are 9 squares and 10 points, and we need to assign these points to each square. This means that there exists at least one square with more than one point, right? So basically we add this thing. Now what we need to find is minimum distance between 2 points, and we need to maximize that. Okay, the maximum case will be here, right? You know, you can just arrange 2 points as we said earlier. We can have 2 points in a square, right? So in a square, in a 1 into 1 square, the maximum distance between 2 points will be the diagonal, right? Understand once try to understand this statement. Okay, so see, we had 2 points. Okay, the maximum distance between 2 points in a small square will be possible when the 2 points are on the diagonal side, right? Once think clearly, it's pretty obvious, right? Because you cannot find any line segment that's greater than the length of diagonal in a 1 into 1 side square, right? So the answer will be the length of the diagonal, which is root over 1 plus root over 1 plus root over 1, which is root 2 centimeters. Hence we proved that the distance apart is at most root 2 centimeters. And thank you.